Welcome back. Today we can discuss an interesting topic under the topic Graphical Method of Solution of a Pair of Linear Equations from the chapter Pair of Linear Equations into Variables. And in our previous videos we have discussed three examples, that is we have discussed about three types of pair of linear equations and we have plotted their graph, and from their graph we have discussed how will be their solutions. Okay, let's go through that. That is, the first example was the pair of linear equations in two variables x and y was x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0, and when plotted the graph, their graph was like this. That is, the two lines which representing the two linear equations was intersecting each other at a single point. Okay, and in this case we can see that this pair of linear equation will have only one solution, and that solution is the point at which the two lines of the linear equations intersecting at each other. Okay, and this type of pair of linear equations can be called as consistent pair of linear equations. And the next example was 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0, and when plotted the graph was like this. That is, the two lines which representing the two linear equations was coinciding each other. That is, all the points lying on the first linear equation is common to both the linear equation. That is, all the points are lying on both the lines representing both the linear equations. In this case, there will be infinitely many solutions for this pair of linear equations, and this pair of linear equations can be called as dependent pair of linear equations in two variables. And in the next case, the pair of linear equations was x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0, and when plotted the graph, the lines was like this. The lines which representing the two linear equations was parallel to each other like this, and that is, they are not coinciding or intersecting at any point. So this pair of linear equation will have no solutions, as they have no common points which are intersecting or coinciding each other. So they will have no solutions, and this type of pair of linear equations can be called as inconsistent pair of equations. These all are we discussed in our previous videos. If you have any doubt, you must watch the previous videos. Okay, and now we are going to see how to find the graphical representation, and from that how can we see the solutions of a pair of linear equations, all without plotting the graph. Okay, for that, first we are taking the pair of linear equations in general as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. In general, we can write a pair of linear equations in two variables x and y like this, and a1 is the coefficient of x in the first linear equation, and b1 is the coefficient of y in the first linear equation, and c1 is the constant term of the first linear equation, and a2 is the coefficient of x in the second linear equation, and b2 is the coefficient of y in the second linear equation, and c2 is the constant term of the second linear equation. And in this method, we are just seeing the ratios a1 by a2, b1 by b2, and c1 by c2, and we are just comparing these ratios to find the graphical representation, and from that the solutions of the pair of linear equations. Okay, let's see it. Okay, the first pair of linear equation is x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. And let's see a1 by a2. a1 is the coefficient of x in the first linear equation. That is, here the coefficient of x in the first linear equation is 1, and a2 is the coefficient of x in the second linear equation. The second linear equation is this one, and the coefficient of x is 3. So a1 by a2 is 1 by 3. Okay, so we get the first ratio like 1 by 3. Okay, let's see b1 by b2. b1 is the coefficient of y in the first linear equation, that is -2, and b2 is the coefficient of y in the second linear equation, that is 4. So we get the ratio as -2 by 4. And c1 by c2. c1 is the constant term of the first linear equation. Here the constant term is 0. There is no constant term here. And the c2 is the constant term of the second linear equation, that is -20. So the ratio will be 0 by -20. And now we have to compare these ratios. Let's see. 1 by 3 is not equal to -2 by 3, 2 by 4, isn't it? And they are not equal to 0 by -20. So in this case the ratios are not equal to each other. So we can write a1 by a2 is not equal to b1 by b2, and they are not equal to c1 by c2 also. And in this case, when the ratios are not equal to each other, their graph will be intersecting lines. Okay, and we can we have when the graph of the pair of linear equations are intersecting each other, they will have only one solution. Okay, and let's see the next pair of linear equation. 2x plus 3y minus 9 equal to 0, and 4x plus 6y minus 18 equal to 0. And a1 is the coefficient of x in the first linear equation, that is 2 here, and a2 is the coefficient of x in the second linear equation, that is 4 here. So we get the ratio 2 by 4 here. And next we can see b1 by b2. b1 is the coefficient of y in the first linear equation, that is 3 here, and b2 is the coefficient of y in the second linear equation, that is 6 here. And we got the ratio as 3 by 6. And next we can see c1 by c2. The c1 is the constant term in the first linear equation, that is here -9, and c2 is the constant term of the second linear equation, that is -80. And we got the ratio as -9 by -80. Okay, let's see, when comparing these 2 by 4 can be, when cancelling each other, we get 1 by 2, isn't it? And this 3 by 6 also, when cancelling each other, we will get 1 by 2. And this -9 by -18 also we will get 1 by 2. Minus cancel, and 9 will go in 18 by 2 times, so we will get 1 by 2. Okay, so these all are equal to each other, that is a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to 1 by 2 here. So when the ratios a1 by a2 and b1 by b2 and c1 by c2 are equal to each other, in this case the graph will be the coinciding lines, that is the graph of this pair of linear equations will be coinciding each other. And when the lines are coinciding in the graph, we can see that they will have infinitely many solutions. Okay, and let's see the next example. X plus 2y minus 4 equal to 0, and 2x plus 4y minus 12 equal to 0. And let's see a1 by a2. a1 is the coefficient of x in the first linear equation, that is here 1, and a2 is the coefficient of second linear equation of x in the second linear equation, that is 2 here. So the ratio is 1 by 2. And next we can see b1 by b2. b1 is the coefficient of y in the first linear equation, that is 2 here, and the b2 is the coefficient of y in the second linear equation, that is 4 here. And next is c1 by c2, that is c1 is the constant term of the first linear equation, that is -4, and c2 is the constant term of the second linear equation, that is -12 here. And let's see the when comparing the ratios, we'll get 1 by 2 here, and 2 by 4 when cancelling we will get 1 by 2, and this minus cancel, and 4 by 12, that is 4 will go in 12 for 3 times. This when cancelling we will get 1 by 3. So this 1 by 2 is equal to 1 by 2 here. That is a1 by a2 is equal to b1 by b2, but they are not equal to c1 by c2. Okay, that is, in this case a1 by a2 will be equal to b1 by b2, but they are not equal to the c1 by c2. Okay, and in this case it is says that their graph will be parallel to each other. That is, the lines of the linear equations will be parallel to each other, and when the graph of the pair of linear equations are parallel to each other, we can see that they will have no solution. Okay, this is the simplest method to find the graphical representation and also about their solutions without plotting the graph. Okay, in the next video we can discuss the examples under this topic. Okay, see you in the next video. Till then, take care. Bye.